UDC.
Good afternoon, everyone. Hope you all have been having a good time here at IMGIS. I know I have been myself, and we're very excited here to present on DTE's iterative approach to migrating to the utility network. So to help tell a little bit about our story, we want to take you back to the beginning. So for us, that means our current state of our GIS, as well as the challenges that we face with our system currently, and some of those business challenges as well. We then want to walk you through, in our mind, what our initial strategy was and how we decided to pair up with UDC to perform a proof of concept and some of those key discoveries that we got out of that proof of concept. Then that takes us then to what our new strategy or our roadmap is and some next steps. So I'm Desiree Weitzmann. I'm the GIS supervisor on the gas side for DTE. Joining me today is Maddie Adams. She's a GIS technician. She's our APDM subject matter expert and our GIS team lead, as well as TJ Houle, who's a vice president solution engineering at UDC. So a little bit about DTE. We're a combined utility company for over 150 years. We've been proudly serving 1.3 million customers. That's residential, commercial, and industrial. We maintain approximately 2,000 miles of transmission pipeline and respectively 20,000 miles, about 20,000 miles each of distribution and service pipeline. And now TJ's going to tell you a little bit about UDC.
Hi everyone, really quick. UDC is proud to be an independently owned enterprise-grade company that provides geospatial services. We are a solution independent services provider, and we're really excited to partner with DTE.
Thanks, TJ. Okay, so let's go ahead and roll back to the beginning and talk about the current state of GIS here at DTE. So firstly, our GIS is divided between distribution and transmission. And from there, we can kind of break it down into four main constituent groups: people, procedures, schema, and software. So if we break that down a little further, respectively, between distribution and transmission, starting with software at the top, this is kind of where we have the most similarities, right? So we're both using ArcMap 10.8.1, both using ArcGIS Online and ArcFM Session Manager, and then we diverge a little with specialized tools. From here, this is kind of where our similarities stop. So next up, looking at schema. In distribution, they're utilizing geometric network with a projected coordinate system, whereas in transmission, they're using APDM with linear referencing and just using WGS84, so it's unprojected. Talking about people in distribution, it's made up of regional union drafters for the mapping, as well as a GIS team for analytics. Whereas in transmission, we are a team of less than 5 non-union GIS editors performing all the mapping. And then lastly, for procedures, distribution is very efficient and has a long-standing process for receiving their mappable work through Maximo, and they have well-developed mapping standards that exist in their area. Whereas in transmission, a lot of these things are still underway and in development. So next we can kind of talk about some of the GIS challenges that we face with our current system. So a majority of these challenges really are due to outdated software and antiquated solutions. So in distribution, there's been a huge focus on ensuring that the GIS looks exactly like you would see it in a paper map with annotation and scaled areas. In transmission, we don't have 3D support to help us with station piping, as well as other linear referencing limitations. And then overall, we don't really have a very good solution or a very good method to kind of help us have some automated integrity checks and really ensure that our data integrity is going to be as high quality as it can be. And we struggle with limited scalability and issues with sharing our GIS overall.
Thanks, Maddie. So now that you've seen what our current state of our GIS is, as well as some of the challenge that system is presenting to us, it's important to take into account some of the business challenges as well. I think that's something that all of us typically are juggling with and trying to move forward as we're planning out our UN migration. So one of the biggest contributors for us of a challenge was the lack of GIS governance. Over the past 10 years since we've migrated into ArcGIS, we've had, unfortunately, a lack of an executive champion. We've had our GIS personnel distributed across multiple groups under different leadership, and most times even understaffed. This is pretty much coupled with multiple and increasing compliance commitments, as well as just a lack of those, like what Maddie was saying before, consistent with our mapping and our GIS standards. So really just what is happening then is we've had an inefficient use of resources, and that's creating some operational inefficiencies. So at that time, after we've kind of looked now at our current state is, we've taken inventory of that, we were starting to look at performing that POC, and I'm going to invite TJ back up to talk a little bit about that.
Thank you. First, I want to talk just a little bit about the scope of the work that we decided to do when we partnered to start looking at the POC. We did two things. So we migrated all of DTE's data into the utility network. However, we only configured a subset. And we chose this subset specifically because we believed that there was the information there that we needed to make important decisions. So it's about 8% of the transmission, maybe under 1% of distribution, overall in total 1% of DTE's complete area. So really good, dense in the southeast area where they thought they might have problems. So that's how we selected this subset with you. Just in general, when we talk about UDC's data assessment program, a part of what we do when we do that assessment is we bring all of the data over so that you're getting a complete picture of what it's going to look like for you when you move to the utility network, what kind of remediation you might need. And so it gives you really specific action plan, really specific data points. And I think you're going to see from the rest of the presentation how that enabled DTE to make really data-driven decisions about their next steps and their approach to moving to the utility network. So,
thanks, TJ. And she's right about that, as you're going to see here in a few slides. But I want to first just start off with what our initial migration strategy was at this point of time when we walked into the POC. So just, knowing our data, we understood that from what you've seen on Maddie talked about, we needed to improve our data integrity. Our distribution and transmission models are separate, and that was causing a lot of duplication, and so we wanted to combine them. We wanted to increase the scalability of the GIS. So like we said before, it's kind of like an aging out system, and we're having problems making sure that the GIS is accessible to everyone, as well as then we wanted to implement full system tracing. So knowing that, and what you've heard what we did with the POC, let's talk about some key discoveries that were made.
All right, so the first thing that's probably top of people's minds when they think about utility network migration are errors. So as TJ said before, they did an assessment of all of our data, so thankfully this wasn't just this little tri-county area where we have all these problems. But a vast majority of our issues are in our distribution space, which is exceedingly challenging for us because, once again, that's really where we have these long-standing and well-established procedures and processes that are going to be more difficult to change when change management comes around. So if we break that down a little bit further into the type of mitigation associated with these different errors, we have three kind of groupings that we're looking at. We have the manual fixes, we have semi-automatic, which means you're touching some records, you're probably running a tool as well, but it's a combination. And then we have automatic, where it's pretty simple. You can probably apply a query and run a geoprocessing tool, and you'll be pretty much done there. So for that vast quantity of errors that we have in distribution, we're pretty much going to have to be touching almost every single one of them due to the fact that the mitigation is going to be a semi-automatic. So there's going to be a lot of workload associated with trying to get our data ready for UN migration. In the transmission space, we have a pretty overall small amount of errors that we would expect because it's a lot smaller, there's a lot less data in the transmission space. And then we have a relatively equal division between those three different mitigation types. So some are going to take more time, some are a little less time. But I don't think we're super concerned with the errors that we have in transmission. So next we could talk a little bit about subnetwork tracing. So there's kind of two general prerequisites for subnetwork tracing. You need to have your subnetwork controllers mapped, and then you need to either have feature connectivity with respect to spatial components, or you need to have association status, right? So you're kind of relating things almost through attributes. So when we were going through the POC, what we found was that we really don't map a lot of these features that are going to be used as subnetwork controllers in the utility network. So that kind of takes away a huge opportunity for us to utilize that subnetwork tracing unless we have an initiative to go ahead and try to review all of our records and map all of those items. So then, feature connectivity and association. So I wanted to provide some examples, and I'd like to ask you to use a little imagination here because they're really just examples. There's so many other instances where we have similar issues occurring in areas where it's really going to create larger problems for having any kind of subnetwork configuration. So for these two maps, just to point out ahead of time, blue is going to indicate transmission data, green is going to indicate distribution data. So on the left, we have a pretty small mainline valve site. You can see some above grade piping, and hopefully you can see well enough in the photo, but we not only have a little bit of shifting or displacement with our T's and our valve features, but we're also lacking that kind of snapping that's happening between these different lines, right? So if we take this example and we apply it to a different setting, right? This could cause us huge issues when we go to try to build a subnetwork because we don't have that connectivity well established. On the right side, we have a gate station where we've got both transmission and distribution in the station. And I'm pointing out a reg building because this is typically where you're going to have those two meeting and butting up to one another, right? But in our instance, we don't have station piping mapped coming into that reg building, and we have no physical or spatial connectivity between our distribution and transmission data. So we would either need to establish that by mapping those missing features, or we would probably be able to utilize association status and kind of relate those with connectivity there, right? Next topic is duplication. So we do, as in our gas company, we have T-pods and D-pods, which are distribution operated by transmission, transmission by distribution, and this creates a lot of issues in our GIS space with duplication because, you know, one person or one group might be reporting those locations to the one call system, so in Michigan that's MISTIG, whereas another one might be running integrity on them because of their classification. So with all of this duplication, and once again, photo for example, transmission's blue, distribution's green, we can see we have spatial disagreement in this entire pipeline. With these instances of duplication, we need to understand whose data is correct, how are we going to verify that, what is the process going to look like, and then which group or model is going to continue to maintain those features in the future. So these are all these business decisions that need to be made and processes that would need to be established. So lastly, one of the big discoveries we made was the change management aspect of it. So I think we all expect a lot of change management, especially in our GIS spaces, when it comes to migrating our data, utilizing new schema, going to a new software. But there was more to it than that, right? Obviously, system architecture and IT functions have to really adapt and change and modernize, as well as the data consumption aspect. So we have, you know, our pipeline integrity group is using our transmission data, so they're going to have to completely reconfigure their risk models, their class calculations, their HCA. Same goes for distribution on the DIMP side. So there's just overall, there's going to be a lot of work there, as well as ensuring that we have the online interactive maps so that people within the company can view everything appropriately. So to summarize, we've talked about a decent amount. So we really don't have a lot in common between transmission and distribution. We are very diversified groups, pretty much in every respect, not only GIS, but operationally in the field, you know, our engineering, everything is kind of handled a bit differently, even with regulatory requirements as well, of course. Our GIS challenges and limitations are primarily due to our outdated software and antiquated schema. The business challenges are mostly due to a lack of GIS governance. Full utility network functionality would require major business commitment, pretty much from what I've described with what I have below here, which is there's a lot of work that we discovered that needs to happen if we want to kind of have that tier 3 utility network functionality that I think would be a true north for us. So at this point, we need to ask ourselves the question, how will we balance maintaining existing workload, staying in support, keeping future promises, and migration-related workload?
Thank you. And so our answer was we needed to change our roadmap. We needed to change our strategy. So to kind of go back to that, what initial one was, data integrity and improving that is still priority for us. And by moving to the UN, that already is something that forces you to do that. And so we're going to get that. But the big change here is now we're no longer going to combine distribution and transmission into one model. We're going to keep them separate, but we're going to align them. That's going to give us time to address some of those duplications and the thoughts of what, where's the delineation of who is mapping what and when. We're going to go ahead and be able to increase our scalability since moving to the UN is really increasing our service base, as well as we're going to be able to modernize our system. But for now, we're going to put on the back burner the full system tracing. We're going to go ahead and work on improving each model's subnetworks and looking at those, being able to map those controllers so that in the future, like Maddie said, our true north would be then to combine. So some next steps on our roadmap here. We've gone ahead and we've submitted our business case for the UN migration. We are waiting on the approval for that. As you can see, we had a lot of data cleanup that needed to be performed. We've gone ahead and started on that in-house. We've started with distribution model, and a little bit has been done in the transmission space as well. The environment for this is currently being built, and it looks like it's projected to be finished here by the end of the year. And then we are targeted then to, when we receive those resources, to go ahead and start the migration, to begin transmission model first in 2026, and then we will go ahead and migrate the distribution model afterwards. And that's key part 2 of our strategy. Because that transmission model, as you've heard before, it isn't as complex and it's a little bit less on the change management side. We're hoping to migrate that, take some lessons learned, and then go ahead and apply those to the migration of the distribution model. So with all that, I do hope all of you here today maybe gain some insights from our experience of what you can do to apply that to your own migration.
UDC